All right, welcome. So I've come inside now after I've taken my measurements from the laser level. And just to recall, we had 30 1/4 inches from where the laser was shooting on the tape measure, okay, to down to the rock, the landing. All right, now again, the laser level was up above the deck a little bit, and we found that it was up above the deck 7 3/4 of an inch. So to find the actual total rise from the finished floor of the deck to the landing, okay, we have to subtract these two. All right, there's several ways to do that, but the way that I would do it is I've noticed that I can't take a quarter away from 3/4 without getting a negative. So I'm going to borrow a whole inch here. Be left with 29 inches, and the whole inch is the same thing as 4/4. So if I add those 4 parts to this 1/4, I get 5/4, and now I have a larger number on top. So 5 minus 3 is 2/4. 29 minus 7, all right, is 22. So we end up then with a total rise of 22, and I'm going to reduce this 2/4 to a 1/2 inch. All right, what do we do with the total rise now? All right, we use the total rise to figure out how high each riser cut will be. Notice that we have this stringer board we talked about. We buy it from the store to look like this. We put it on its angle, okay? We're going to have to cut notches out of it. We've got to cut some tread cuts, or some riser cuts. Here's a riser cut, and here's a tread cut. Now we keep doing that, and we've got our steps. Now we've got to figure out then what the distance is of this riser cut. That's what we're going to use the total rise for. Alright, so you got to start somewhere. Okay, and the thing that you start with, at least the thing that I start with, is what's the code in your jurisdiction. Okay, and usually there's a code that says, hey, you can only make your riser cuts so high. Okay, your risers can only be so high. They don't want people tripping or trying to really reach high. And they also have to be consistent, the same throughout the whole staircase. Alright, and generally speaking, or a lot of the codes that I've seen say that, hey, you can't go higher than 7 3/4 of an inch. Alright, so I'm going to start there. Let's see how many rises I'd get if each of them were 7 3/4. So I take my 22 and 22.5. Okay, and I'm going to divide it up into these lengths to see how many rises I will get. Alright, in my calculator it gave me 2.9. Almost 3 full steps. Now, can I just say, hey, let's just make 3 steps. One of them's going to be a little shorter. There's a little bit of tolerance, but I'm not going to risk it, because really you're supposed to have each of them you're supposed to have each of those rises consistent. So I'm going to round this up, saying, hey, actually I'm going to need 3 steps. Okay, but they're all going to be a little bit shorter, okay, than my 7 3/4. So how do I figure out what that measurement actually is? 22.5, and I'm going to divide it up into 3 steps. All right, so when I did this, I found that I got each rise should be 7.5 or 7.5 inches. Okay, so that's quite the difference, right? If I would have tried to make 7 3/4 of an inch each of them, those first 2 steps would have been 7 3/4, but then the second one would have been like 7 inches. That's quite a big difference. So just to recap, we took our total rise divided by what the code was, and we came up with, hey, we need 2.9 steps. We can't have a 0.9 of a step, so we rounded up to, hey, let's see what it is if we have 3 steps. Then I took those steps and those number of steps and divided the total rise to give me, hey, what each rise would actually be, what each unit rise or what each riser cut would be, and that's 7.5 inches. Okay, so from here to here is 7.5 inches. Okay, the next thing we have to figure out is, well, what about this run here, from here to here? How are we going to notch that out? Again, the code kind of is a base starting point. And usually, or at least the codes that I see, are 10 inches is a good minimum. Okay, now there's a minimum with tread cuts because you don't want it to be too small of a thing that you have to put your foot on. All right, so we got a 10-inch minimum. Now, if you're not concerned, if you don't have to have any constraints as far as how far out you have to go, okay, then you might as well just put it at 10 inches. Okay, so for this one, I'm just going to put it 10 inches, but realize that if you have a landing that's already poured and it's way far out, you might have to increase that. Okay, or if you have a wall here that's in front of where you're landing, okay, you may have to be at the minimum because you can't go any further out. You're going to start running into that wall, or you're not going to have enough clearance to turn around because there's a code for that too. Okay, so there's just a couple situations where you might have to do something other than just, oh, let's just do 10. But I'm not going to go over examples of those explicitly. Okay, so we've got a couple more, just a few more pieces, and then you guys should be ready to do that worksheet that I have. Okay, so we have a unit rise or a tread cut, and we have the unit run or a riser cut and tread cut. Okay, we do not have, though, the total distance from, the total run, what the total run would be. All right, now I'm going to kind of cut this out like it would be to Stringer so we can kind of see a little bit better what it would look like. All right, so you'd have some sort of subfloor or landing that you're going to go up against here. And here's my finished floor. And your stringer is coming up here. I gotta get rid of this 22. Get rid of this math here. Okay. So now why did I only draw 2 steps? Are we supposed to have 3 rises? Well, we do have 3 rises, but if you notice, I'm using the subfloor here as my 3rd rise. And that's very common to do, okay? So in other words, I'm going up 1, 2, 3. I still go up 3 rises, but my stringer actually only has to include 2 of them. All right, now there's situations where that might not happen, okay? Might not happen. Including the picture, the video that I showed you earlier, they actually, on the deck, the landing they did on the deck, they did not do it this way. Instead, they did it like this, okay, where they actually included the stringer they actually included this as the 3rd rise. Now, why would they do that? Probably, I'm guessing, because they wanted to go out to the landing, which is farther out this way. All right, so they had actually a distance. The landing was out here like 36 inches. Okay, so they had to get to the landing, so they had to have a little bit more horizontal distance. Okay, now in order to do it this way, okay, you just have to think through each individual situation. Okay. I'm going to focus, though, in the terms as far as on your homework and the practice is this situation, okay, where you're actually using the subfloor for the 3rd rise. Okay, the last 2 pieces that I want to make sure we understand is to find the total run and then to get an idea, approximation of how long of a board you need to buy from the store in order to have your stringer. Okay, so the total run is pretty easy. All right, we calculated that each one of these is going to be 10 inches. All right. So how many of them do we have? Well, we have 2 of them. Notice that that's 1 less than the amount of risers we have. And that's, again, because we're using the subfloor as one of our risers. All right, and we don't need a tread down here at the sub-base floor because that's just a plain old floor of the landing. So our total run is pretty easy. We just do 10 times 2, and we get 20 inches is our total run. All right, now what about the length of the stringer board? All right, well, that's going to be a diagonal distance because remember our stringer board used to be this diagonal thing here. All right. So what are we going to, how do we know how much this is? What are we going to buy from the store? Well, we can use Pythagorean's theorem to help us out. You can just go buy a board that you know will be long enough and then just waste the rest of it, okay? Just since this is a math class and we're learning to be a little precise, okay, I'll go ahead and do Pythagorean's theorem to give you a closer approximation. All right, so total run from here to here, or total rise from here to here is 22.5 inches. Okay, so if I were to square that from here to here and to square the total run and add them together, and then take the square root of that using Pythagorean's theorem, I'd find my diagonal. When I do that, all right, once I do that, I get 506.25 plus 400, which then equals 906.25. Once I take the square root of that, I get 30.1 inches. All right. So when I go to the store, okay, I'm going to give myself some extra room in case I, need some help or mess up or something like that. I'm going to give myself some extra, okay, some waste. So I would just round up to 36 inches because that's 3 feet. But you may not be able to buy a board that's 3 feet long. All right. So usually they come in even foot increments, so I'm going to buy a 4-footer. All right, and for stringers, usually you want to buy a 210 2x10. So I'm going to buy a 4-foot 2x10 board from the store. Now, if it's an exterior stringer, I'm going to buy a treated wood. Okay. Even if it's interior, I might want to buy treated wood anyway if it's touching a concrete surface. That's the basics of. You should have enough of your information. You should have enough information to be able to complete the worksheet.